So we're going to do number 11 from lesson 13.4. We're basically just trying to find vectors t, n, and the curvature of the space curve. So t is pretty simple. You just got to take the derivative of the function, right? And then just find the magnitude of the derivative and divide over each other. And so as there are trig properties, we get basically root 2 times e to the t. And then the e to the t, we can factor out this from the top, so the e to the t's cancel, so you just left with this cosine minus sine t plus cosine t plus sine tj over root 2. So then for n, it's you just have to find the derivative of this curve and then find the magnitude of that curve. So the first part's pretty simple, right? So you just have to find the magnitude, the derivative of this, which is just take the difference each component. So you get negative sine t minus cosine t over root 2i plus negative sine t over plus cosine t over root 2j. And this last part one is a little bit messy, right? It's just a big freaking trig property. So basically, when you multiply everything out, you end up realizing that you end up having two sets of sine squared and cosine squared, and you have a positive 2 sine cosine t and a negative 2 sine cosine t, and those cancel, right? So it's just 2 times 1/2 of sine squared plus cosine squared, and 2 times 1/2 is 1, and the square root of 1 is 1, right? So that ends up being the normal vector, just this top part. And then the k is just the magnitude of dt of the derivative of t, which is 1 as we just found, times the magnitude 1 over the magnitude of velocity, which is root 2 times e to the t. And so then you just get k as being 1 over root 2 times e to the t. And yeah, that is number 11.